Welcome to another episode of Between Two Plants. I'm your host, Ian Fife, and today's guest is Harley Schreiber. Welcome, Harley.
Thank you, Ian.
So Harley is a Chief Process Engineer here at WesTech, and we're excited to have you here on the show today to talk a little bit more about what role you play here at WesTech and what process engineering capabilities WesTech has and your team. So why don't you first start out, tell me a little bit about how long you've been involved in industrial water processes and applications.
Yeah, well, when I came to WesTech, it was about 10 years ago. That's probably when I really got into the water and wastewater treatment area. Before then, I was, like many decades, doing technical design of solid liquid separation equipment. So it was kind of a natural fit to get into the water treatment area, wastewater treatment, because of the solids liquid separation equipment is so prevalent in that process.
Would you say it was a plethora of decades?
I would say it was 4 decades.
What drove your interest and how did you get involved in this field?
Well, I really like the chemistry aspect of it, understanding how to remove contaminants using physical chemical, as well as, of course, my background in solid liquid separation and my a natural interest in learning new and diverse things and always expanding my knowledge. So this is a good fit for that.
And great. And remind me, what's your educational background?
I have a chemical engineering degree from the University of Alberta.
A Canadian, Canuck, all right. Harley, what do you enjoy most about the water treatment field?
Well, in addition to, as I mentioned, diversity and learning different things, probably the biggest thing is the positive contribution we make to the environment. I mean, it's one of WesTech's core values, and it's really, it's a nice feeling to know that we're doing our job and still improving the environment while doing that.
It is nice to have a good mission that's behind us. Let's dive a little bit more into some of the things you do on a day-to-day basis. Some of the things we're going to talk about first are flow sheet development. Tell me, what is a treatment flow sheet development?
So we're given a task or a problem from a customer has a water or wastewater that needs to either discharge to environment or for reuse in their plant. We need to come up with a scheme to treat that water, get it down, get the constituents down to a level that's acceptable for their needs. So this flow sheet development is putting together the pieces to make that treatment happen.
Harley, that sounds complex. How do you get started? Where do you go first?
Well, first thing, we want to come up with a conceptual design. So we're going to know what constituents or contaminants we need to remove and look at what processes would be needed for that removal. We're going to use our past experience from that particular industry, although we have to keep in mind that industrial water is very complex and it seems like there's no two treatment processes that are the same. So we need to get all of that together to design this concept.
Is that frustrating for you, or does that add to the enjoyment or the excitement of this job and your role? Having we always talk about this concept that every water is different. Tell me about that. Is that good? Is that bad? Do you like that? Do you hate that?
It's really challenging, and it adds to the interest of the job. You're never doing the same thing twice, and so you're constantly learning new processes, new treatment methods. So really, it makes it for an interesting job.
So as a manufacturer, there are certain products and technologies that we have to treat different contaminants or applications. Do you, when you're doing your steps in your process, are you limited by the technologies that we have in house, or how do you approach that to make sure we're solving it the right way?
Well, WesTech has a number of different technologies to draw on. For example, we have both high rate clarification, more standard conventional clarification, membranes, reverse osmosis, sand filtration. But in cases where there's equipment that we don't supply, we will work with others to get the necessary equipment for the process. We have options that we will use in our process design.
Oh, great. So you've got a lot of tools in your belt, plus then if the tool is not there, you have the capability to go out and find that tool somewhere else. So.
Yes.
Harley, can you outline some of the important steps and the considerations you go through when you're coming up with a conceptual flow sheet?
Yeah, well, the first thing we need to do, of course, is make a list of all the contaminants or constituents that we need to remove and down to what levels we need to remove them. Because all constituents, or most of them, they're going to need different treatment methods to reduce their concentration in the water.
And how do you know? Where does that list of contaminants come from? Is that something that we do? Is that something that comes from the customer? Where does that list usually come from of contaminants?
Yeah, it's often going to come from the customer. They'll know what their permit regulations are or what their water quality needs are for their process. So they'll typically give that to us, and then it's our job to take those constituents and find out the right proper treatment for them.
And speaking of constituents, can you give some examples of, based off of what you need to remove, how that can change or impact the process design?
Yeah, there's a lot of examples. I can think of a few. Arsenic, for example. Arsenic needs to be oxidized in order to precipitate it in a physical chemical treatment step. On the other hand, chrome, if you're trying to remove chromium, it needs a reduction and at a low pH. So there's two different approaches there. If you look at sulfate by precipitation methods can only get down to a certain level, and that level is typically much higher than a level needed for your permit regulations for discharging to the environment. So that's going to mean you need perhaps reverse osmosis, which creates another concern because now you have a large waste stream, RO reject, that you have to treat.
So Harley, the customer provides us with water quality data that shows us what's coming in. There's also effluent requirements, right? What's required going out, whether that's based off of the discharge permit or whether that's based off of the whatever process that it's feeding into that has certain requirements. How do those effluent requirements impact the process that we're dealing with?
Yeah, it has a big impact. If you need to get down to extremely low levels, that's going to require much more intensive treatment, which might be polishing with filters, membrane filtration, reverse osmosis. So yeah, it's a critical part and a consideration that we have to keep in mind.
So you've got your ins, your outs, and you've got to make it all balance and work out, don't you?
Right. Yeah.
Okay, so Harley, we've considered the influent water quality data, the effluent requirements of what it needs to get down to. What's the next step?
Well, we need to decide which equipment is going to be suited for that purpose and do the preliminary sizing of that equipment. What size equipment do you need to get the reaction to proceed? What size clarifiers? And that will go into our flow sheet development.
And how, on some of that equipment sizing, is that based off of programs that you have, that we have? Is it based off of experience? Is it based off of just thumb in the air?
Well, it's based on our experience. WesTech's been doing this for many, many years, decades. So we have a database built up of where things should fit in, but that's just the starting point. We need to go on to lab testing.
So it sounds like we know, okay, we've got these different pieces of equipment that we're going to need in order to build out this flow sheet and to tackle this water challenge. You mentioned lab testing. Why is lab testing important in the development of the flow sheet?
Well, lab testing is really going to confirm our concept. We're going to make sure that we get the right sizing. The other most important thing about lab, it'll tell you if we can achieve the requirements we need for discharge limits, for example. And if we need to, therefore, maybe change the process flow sheet in order to accommodate that. It's all determined from the laboratory testing.
So Harley, as we're going through the lab testing step, what are some challenges you look out for in working on that lab sample?
Well, the biggest thing is we have to have a representative sample to ensure that what we're going to treat, our treatment scheme, is for that specific water.
When you say representative sample, you're referring to whatever we're dealing with and testing in the lab, that it's representative of what is actually going to happen and be out in the field, right?
Yeah.
And so what are some of the challenges in making sure that you have a representative sample?
Yeah, there's a lot of challenges. For example, the actual processed water that we're going to treat might change from time to time. It may fluctuate seasonally. Other issues, collection of the sample may be difficult to collect a representative sample. Bigger challenge is if the process or plant that you're trying to treat isn't operating, they may not have a sample available to test. In which case we need to perhaps simulate a sample the best we can, get a sample from a nearby installation or something like that.
So Harley, we've got the lab testing that we've completed, or that we're in the process of completing. How does that impact the outcome of the flow sheet that we're developing?
Well, I think one of the big things that lab testing does is allows us to optimize the process. If we're just going through a conceptual design, we're going to make sure that everything is designed conservatively so that we know that it works. But going in the lab then lets us optimize and not over-design things.
Harley, we talked about the importance of having a representative sample, but as we all know, sometimes conditions fall outside of those representative samples. What steps do you take, and how do you work with the customer to deal with some of those anomalies?
Often the water, as you mentioned, is going to change, maybe seasonally, but you need to work with the customer to understand, do we design the equipment to handle those anomalies that may only occur for a short period of time, or do we look at things like some redundancy of equipment that can be put online in those situations? We can look at reagent consumption. If we increase reagent dosages, can we get out of those situations in those periods of anomaly?
Yeah, and I imagine there's probably also a certain amount of turn down capacity on the equipment and things where you don't have to run it at full capacity, but maybe you do under certain anomalies and peaks and things. So no, that's fascinating. That's what makes this job so interesting and fun, is there's never a one size fits all approach to how we handle these different water treatment challenges. Speaking of challenges, tell me a time or an example where maybe lab testing and things didn't go quite as planned.
Yeah, we had an example where we didn't recognize how this sample would change during shipment. And this particular example was arsenic removal. And as I mentioned, arsenic needs to be oxidized in order to remove it. In the lab, we were able to remove the arsenic very easily. No chemical oxidation was needed. And we should have known that during that transfer of that sample, the sample naturally oxidized. So that was a learning experience that we won't forget that again.
We've talked a lot about treatment flow sheets today and all the different steps that go into it. What do you enjoy the most about developing these flow sheets?
There's a few things. We've mentioned the wide variety of things that we see, different flow sheets. It's always changing. It's never the same. And one thing I really love to see the predictions of chemistry play out in our lab testing. It seems obvious that we've studied chemistry, we would expect these things to work. But for example, we did a very thorough test where we raised pH and got removed metals as a function of pH. And the results that we got proved all of the things we talk about every day. The aluminum wasn't removed well at higher pHs. Manganese removed better. The metals removal always got better at higher as the pH got up. All things that are basic, and you should take them as the truth, but it's fun to watch those play play out and see the results of those. And another thing we really enjoy about it is how our lab predictions end up with a successful plant and accurate predictions of the performance. Designed a large plant, large clarifier. The metal removal was exactly how we predicted. Even the underflow concentration was right where we thought it would be. So when you get those successes, that's really makes it worthwhile.
Sounds like it provides a lot of real fulfillment
Yes.
In what you do every day.
Right.
Yeah, very good. Well, Harley, it's been great having you here today. Sounds like you have an important job and role here at WesTech. Quite an important service that you offer and your team as far as helping customers take a look at their unique challenges, their a variety of influent characteristics, different effluent discharges, and saying, hey, how can we help you solve this? And then taking it from paper all the way till seeing it happen in real life. It sounds like it's a really critical step in water treatment and in developing solutions for customers. So very fascinating. It's been enjoyable learning from you, and appreciate you being our guest today.
Thank you. It's good to be here.